Hello everyone, my name is Viraj and today we'll be looking at the 13th problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here. I have ticked off the 800 rated parameter and I'll click on my 13th link, United We Stand. So let's read the problem. Given an array A of length n containing integers and there are two initially empty arrays B and C, you need to add each element of array A to exactly one of the arrays B or C in order to satisfy the following conditions. Alright, so I think up till here everything is very simple. I just need to add elements to B and C. Both B and C arrays should be non-empty. More formally, if let's say the length of B is given LB and the length of C is given LC, then both LB and LC should be greater than equal to 1. So this is a very important point, basically saying B and C should be non-empty at the very end. And then they have given a very strong point over here that we want to follow. For any two indices I and J, I know that Cj is not a divisor of Bi. Alright, so what do they mean by that? We'll of course discuss the problem and understand this in more depth. Now they have said you will output the array B and C if they can be obtained, or you will only output -1 if such a case does not exist. Alright, great. Let us try to generalize this problem and understand what are they asking us. Alright, so of course we begin by a very simple thing. They have given an array A to me. So I'll take up the numbers. I'll say okay, A1, A2, A3, so on till AN. Alright. And then when I have created such a numbers, I basically have, so this is AN. Then I have an array B initially, which is empty. And I have an array C, which is also empty. Now what I'll do is, I'll simply just start picking up some elements wherever I feel is necessary and place them or add them to either B or C. So I can be like, okay, let's take A1, let's maybe keep this in B. Let's take A2, let's maybe keep this in C. A3, let's in B, and so on, so on, so on. So I need to just allot some element to say, okay, you go to B or you go to C. So let me just do a very simple allocation. I'll just assume, okay, that I gave B, the array B A1, A3, and so on. Let's say the last element AN. And let's just say the leftover elements A2, A4, and so on. Let's say A of n minus 1 or something like that. I just gave this element off to the array C. Alright, just bifurcating some elements to go to B and some elements to go to C. Now they have given you two conditions, right? They are giving you two conditions. One is very important. The size of B and the size of C should actually be greater than 1. So you can see over here, I have allotted some elements to B and I have allotted some elements to C. I could not have done such a case where I allot everything to B and C remains empty. No, that's not allowed. Or vice versa, I could not have taken such a condition where I would have allotted nothing to the array B and everything to array C. That's also not allowed. So at the very end, I know that I want the size of B, or you can say the length of B LB, and the length of C LC should be greater than 1. Both of them should be greater than, not greater than 1, greater than equal to 1. As in, at least there should be one element I actually give B and C both, right? Nothing can be empty. Now they have given one more very important point, right? So let's look at the point 2. That's what we are focusing right now. They've given you a very formal justification over here that let's say you pick up two indices I and J, where I is belonging to 1 to LB and J belongs to 1 to LC, then Cj should not be a divisor of Bi. What does this mean? Very simply, what they are trying to convince you of is, if let's say you have given up some elements to the array C and you have given some elements to the array B, so any element I take in C, should not divide any element I have taken in B. Any element. That means, let's just say I take up any random element. Let's say I take A4 and let's say I take any random element from it. Let's say I take AN. So I know that AN modulo A4 should not be equal to 0. As in, A4 should not divide AN. A4 should not be a divisor of AN, right? So now you can see A4 is taken from C and AN is taken from B. So if I generalize this, what they have written is like this. They have said, okay, if you have some random number from B, let's call this Bi, and some random number you take from C, let's call that Cj, then Cj should not divide Bi, or Bi mod Cj should not be equal to 0. If it is equal to 0, then that is not a correct thing you have done. You want that this case is true. it should not give modulo value to be equal to 0. Okay, it should not be equal to 0. Alright, so I think this has become very, very clear that this is how I want to bifurcate my Rn. Alright, so now what we'll do is we'll quickly look at the test cases and we'll further understand what are they trying to picture. Okay, so let's take up the very last case, 4, 8, 12, 4, 4. So I'll write this case over here. You have 4, 8, 12, 12, and then I think you have 4 again. So 4, 8, 12, 12, 4. Yeah, correct. So now what they have said is you can take the array B and fill it with the first, second and fifth number. So let's say this becomes 4, 8 and 4. And let's say you have the array C and this can become the rest two numbers, that is 12 and 12. Now if you look very carefully, both arrays have some numbers in them. Of course, C has size greater than equal to 1 and B has size greater than equal to 1. So condition 1 is I'm blind, yes. Condition 1 is true. I know I have created such an array B and C where the length is greater than equal to 1. But if I look very closely, if I pick up any number from C, let's say I pick up this number 12, and I pick up any number from B, let's say I pick up even the number 4, then I know 4 modulo 12, is it equal to 0? No, it's actually equal to 4. So it's not equal to 0, which makes me argue that 12 was not a divisor of 4. Now if this 12 would have been taken with 8 also, it would not have completely divided 8, as in 12 would not have been a divisor of 8, and then of course this 4 also. Now if you change your value, that's Cj, to any other value, let's say I would have taken this 12 instead, not the first 12. Same case again, because 12 and 12 are same. So very arguably you can say any element taken up from C, any element, let's say I take up this or this, and any element taken from B, I know Bi mod Cj is not equal to 0, as in Cj is not a divisor of Bi. So this is a correct sort of a bifurcation, and this can be printed. What are they finally requiring you to print? You have to print the sizes of both the arrays. So what they've done over here is they have printed 3, then 2. So this basically depicts that, okay, size of the array is 3, then the size of the array C is 2, and then you will print the array B, and then you will print the array C. Now I don't think they require any order, right? They are very clearly written. You can print the elements of the array in any order. So you could have also printed like 4, 4, 8. This would also have worked. Doesn't matter. Okay. So very, very important point and a very strong test case that can build our foundation on how we solve the problem. Alright, so I hope the test case has now become clear. You can of course pick up your pen and paper and get going with the other cases, and you will very surely get an idea of what do they mean when I say, okay, the answer is -1, and why do I mean that the answer is this. Alright, it makes sense. Now, of course, we'll move on to how do we actually start off with our idea. Before we actually start off, we need something in our head. We need something which directs us toward the correct solution, and we can start building on time complexity first, right? So if let's say I ask you what is elementarily in 1 second allowed, you will say, okay, I have been allowed 10 power 8 operations elementary in 1 second. Now how much have I been given in this question? Time limit per test is 1 second. So if I talk about one test, that's basically saying that in one test, basically I have been given 1 second. I'll write this down. One test equals to 1 second, which means I have been basically given 10 power 8 operations. Now, if we go back to the question, every test has some test cases. Yeah, each test consists of multiple test cases, and test cases go in 500 order. So if I ask you what is the number of operations you are allowed for each test case, then what can you argue? I can simply say this is going to be in 1 second 10 power 8 operations upon 500, which is somewhat like 1 by 5 into 10 power 6. So I can argue this is somewhat like a 10 power 6 order, right? Somewhat like a 10 power 6 order, not exactly. Or just if you go very acute on the mathematics, this would be like, I think, 0.2. So this can be 2 into 10 power 5. So this can be 10 power 5 order better. I think this is my mistake. We should not write 10 power 6. Something like 10 power 5 order is actually available to me to operate for each test case. That is the number of elementary operations. Alright. Now based on this, I can create some solution in my head, as in what's the expected time complexity. Now I have n with me, n is given in 100 order, and I'm mostly bothered with n. So assuming that my time complexity is actually bothered with n only, I know that I can create an n square solution. Yes, that would be good to go if assuming n is 100, that's the largest limit. If I go above this, n cube is not available because n cube creates n 10 power 6 and I want to go till 10 power 5 per like elementary operations per test case. So this is not allowed. This is of course allowed. And if this is allowed, anything below this is allowed. O of n is allowed automatically. O of n log n is of course allowed. And so on, so on, so on. Even if you go till the best time complexity, that's O of constant, like O of 1, then this is also allowed. So I have an upper bound in my head. I don't want to go in n cube order, but if I go in n square order, it would be fine. Not that I want to go in n square, but again, it doesn't harm me to go in that case. That's the upper bound I can go. So I have an expected time complexity in my head that, okay, n square is something I want to achieve, or n square or anything below, is something I want to achieve. I'll be good to go in that part. I will definitely get an AC, not a TLE at all. Okay, great. So now I have an expected thing in my head. How do I start off with the problem, right? First and foremost, I need to ask very, very simple questions. All right. How do I make sure, or in what cases I'm never able to make sure, if I look at the other case to figure out the -1 part, how can I never make sure that I find numbers to put in C which are not a divisor of B? All right, let's think again. Let's say you have been given the array A, and let's say every number is same. Let's say you have the number 5, 5, 5, 5. You have 4 5s. Now, of course, 5 is going to divide 5 to itself. So when you have the array B with you and when you have this array C with you, and you will ask the question, what should I put in B and what should I put in C? It doesn't matter. Although you would be able to complete the condition that you create sizes greater than equal to 1, as long as you are putting some 5 over here and other 5 over here, this 5 is going to divide this 5 and your condition never satisfies. So I can very clearly see that if the array A has same elements, then I know that the answer seems to be -1. Because if I have same elements, of course those same elements would be going in array B also, and they would also go in array C, and going them in array C numbers will automatically divide the numbers in array B, and that condition of second part, that CJ should not be a divisor of BI, doesn't fulfill. So this creates a -1 case. Now the argument actually, like the underlying argument states, is very, very simple. Building on this idea, I can say something like this. I'll write down the argument. If I have more than one distinct element, then I can say, then the answer exists always. This is my argument. Okay, exist always. Why? Let's ask us why. All right. So we have obviously counteracted the case when I see -1, right? -1 case simply meant the elements are same. So basically you have only one distinct element. Now my argument is, if you have more than one distinct element, the answer always exists. You can always create an answer where you satisfy the condition of B and C. Let's try to picture how. Assume that you had more than one element. Just let's take a very simple case. You had two distinct elements. So you have the array A, and let's say the element 5 was there, some more 5s were there, but then, oh no, there was one more distinct element. Let's just assume some number, let's say 7. Now what can you actually do? How do I make sure that a number never divides any other number? If let's say I have written the number x mod y, and if I want not equal to 0, this condition should always to be true, then can I just simply say, if y is greater than x, then this condition is always true? Yes. What do I mean by this? Look at the array. You have a very high number, the highest number in this array, that's 7. How about I simply say, I'm going to put this maximum or the highest number 7 in the array C, and rest all the material I can find in the array B. Now, what is that going to help me do? Of course, it creates the non-empty case. I know that it does not create a non-empty case. I have the size of B and C both greater than equal to 1. But now, because every element in array C is the max element that was there in the array A, I know that it's going to never divide any number in array B. Because to divide, let's say if x wants to be divided completely by y, then y has to be y has to be less than equal to x. So if I always make sure that y is greater than x, if I always focus on y being greater than x, then I know that I will never create this condition and x mod y will always be not equal to 0. And this is what I'm doing. Since I know that the elements I put in C are the largest possible elements, they are the maximum elements in the given array A, they will never divide any other smaller element, right? Any other smaller element from the array A which I throw to the array B. Alright, so very, very clever and very fun idea. So this proves our argument that if I have more than one distinct element basically in my array, then I can just make I can just say C array is going to have all max elements, as in if let's say maximum element is coming 3 times, then I'll put 3 max elements, as in that maximum element 3 times, so on, so on, so on. So that is what I mean by saying all maximum elements. And B is going to have everything beside max elements. Alright, max elements. Alright, so I hope this clears up our idea. Now we'll quickly look into the code part and just picturize how can we implement this thing to get an accepted solution. Alright, great. So I'll move on to the code. Very, very simple. You begin off with your test cases, and then what you can do is you can just take the input of this array n, the integer n, that's the size of the array. Then I have created a array or a vector in this case. You take input of that. Now I have ran a simple STL function to get back my maximum element in the array. Why am I doing this? Because when I create a vector b and a vector c, for me, I know that I want to push back all the elements which are not maximum in the array B, and I want to push back all the elements which are maximum in the array C. So this basically creates a very simple if check for me. If AI, that's the current number, is not maximum element after I've extracted the maximum element by writing this syntax, dereferencing maximum element a dot begin to a dot end, that's completely saying for the whole vector. If this is not maximum, push this in array B, else push this in array C. Alright, and now what do I know? I know that we discussed, if you have been able to create the array B and C successfully, then what will happen essentially? Let's say that you had only one element in the array. If you have only one element in the array, then you will never push back anything in the array B, because that one element will be equal to mx and everything will be pushed back to the array C. So if you have only one element in the array, that is when we talked about the -1 case, it will always be pushed in array C, and that will make sense that B's size was 0. So if the size of B is 0, that means all elements are same and hence max. And if that is the case, I will print a -1, because this tells me I was not able to create B and C arrays separately which have basically greater than equal to 1 size and also have the divisor condition fulfilled. Else, I know I have successfully created the array B also and C also. I will just print first line their sizes, B size space C size. Then I will just go to a for auto loop, print everything in array B and then everything in array C, and this completes my final answer. Alright, now what is the time complexity? If I look over here, this is basically O of n to take the input. Again, finding maximum also is like an O of n operation by STL library. Over here also you have an O of n operation and all this pushbacking is constant. Then time complexity over here would be n, not approximately, like you can say approximately n, not exactly n, because B size is not going to be exactly n, but in an order of n, and similarly this can also be reported in order of n. So simply the superseding turns out to be O of n. I don't need to think any further. O of n is a decent time complexity I can report into. And what about space? Of course, I'm using some extra space. First, I'm taking some input, that's size n. Then B and C also is extra space of size n at max. So order of n actually at max. So I can say space is also O of n. Now we discussed that we wanted to go till O of n square, but we have been much better creative on our solution part. We were able to create in O of n only, which is very good to go. This creates a solution for me in O of 100 time complexity basically, which is definitely within my boundaries. I'm going to get an accepted, not a TLE at all. And same goes for my space order. This is also like O of 100, which is very, very well within my boundaries. Okay, so very clever problem, I should say, right? Just to understand that, okay, when would I always make sure that divisor thing is going to work is what we had to identify. Once you identify this part, this is a very simple implementation based problem. Just bifurcate all the maximum elements to the array C and rest everything in the array B, and then put your if and else checks accordingly. Okay, so I hope you like the video. Thank you for watching.